Hi and welcome to this video. Today I'm going to be discussing how you use moles to convert between mass and number of moles. And later in my next couple of videos I'll actually explain how you can then apply those into chemical reactions. My previous video looks at what is a mole and the idea of counting atoms in terms of mole by weight and using moles. If you haven't already checked that out, I suggest that's where you start. So when we look at a chemical reaction, what it tells us is how many atoms are reacting. So what are the types of atoms that are present and how many of each is involved in a reaction. So for any specific reaction, the balanced equation tells us a lot about what's actually happening in terms of how many particles of each substance are present and how they convert. We can use that to calculate how much product we might find, how much reactant we might need, and other things in between, but only if we can figure out how many atoms we have present. And that is where our friend the mole comes into it. We need to be able to count atoms. So to do that, we need another good friend, and that is the periodic table. So when you look at the periodic table, for any entry, for any element, there are usually two numbers. Now, some periodic tables provide more data as well, but pretty much all of them will provide these things. The symbol, usually the name, but not always. The atomic number, which is the whole number, the smaller number, that's the number of protons in the nucleus, and the number of electrons in the valence shells. And then we have this other number, 35.45, if you look at chlorine for a second. Now, when you were in year 9 and year 10, and probably even in year 11, to an extent, your teachers told you that that was the mass number, the number of protons and neutrons in the nucleus. And a few of you might have even looked at that and gone, well, that's pretty weird. How do I have 18.45 neutrons in chlorine? Because I can't get half a neutron. It's either a neutron or it's not a neutron. So what this number is actually, this mass number, is the mass of 1 mole of atoms. Okay, so if I have 1 mole, 6.022 times 10 to the power of 23 chlorine atoms, that will weigh 35.45 grams. It is the average mass, average number of protons and neutrons in each atom, and it's averaged because we have different isotopes, which are atoms with the same number of protons but different numbers of neutrons. Okay, so the periodic table tells us the average molar mass, the mass of 1 mole of that substance. So if I have 6.022 times 10 to the power of 23 chlorine atoms, it will weigh 35.45 grams. And if I have 35.45 grams of chlorine atoms, then I can be pretty confident that actually I've got 1 mole of chlorine atoms, 6.022 times 10 to the power of 23. So that's all well and good. I can work out what is the molar mass of any element by looking at the periodic table. But most of the time in chemistry, we're not looking at elements, and certainly not just simple atoms. So if I have a compound or a molecule, it could be a molecule of an element, any substance that contains 2 or more atoms, they could be of the same type of atom, they could be different types of atoms, I can still work out the molar mass of that substance. So for simple elements like copper or sodium or helium, I can just look at the periodic table. It tells me the molar mass of that element and away we go. If I want to work out the molar mass of a compound or a molecule, then I need to add up all of the individual molar masses of all of the atoms that make up that substance in the appropriate ratios or quantities. Okay, so let me show you what I mean by that. Let's consider first oxygen gas, O2. It is an element, but it is also a molecule. Okay, so a molecule of oxygen gas contains 2 oxygen atoms. That's what the formula O2 stands for. So if we want to work out the molar mass of oxygen gas, we need to take the molar mass of the oxygen atom. There are 2 oxygen atoms in a molecule of oxygen, so we add them together and get 32 grams per mole. Molar mass is always recorded in units of grams per mole. That's g mole to the -1 for those of you that aren't really comfortable with the -1 things meaning per. Okay, so 32 grams per mole. We can look at something slightly more complicated. Let's take sodium chloride. Sodium and chlorine. The formula tells us that there is 1 sodium for every chlorine. So when we want to work out the molar mass of sodium chloride, we simply take the molar mass of sodium, which is 22.99, and the molar mass of chlorine, which is 35.45, and we add them together. So the molar mass of sodium chloride is 58.44 grams per mole. That means if I want 1 mole of sodium chloride, then that would weigh 58.44 grams. Similarly, if I have 58.44 grams of sodium chloride, that means that I have 1 mole of sodium chloride, or 6.022 times 10 to the power of 23 particles of sodium chloride. Okay, some more examples. Water is a molecule. It consists of 2 hydrogen atoms and 1 oxygen atom. So to work out the molar mass of a water molecule, I'm going to need to take the molar masses of hydrogen, of which there are 2, and the molar mass of oxygen, which there is 1, and add them all together. And we find that water has a molar mass of 18.02 grams per mole. In other words, 1 mole of one mole of water molecules weighs 18.02 grams. We can follow exactly the same process even with much more complicated looking molecules, such as our friend glucose, which has the formula of C6H12O6. And again, we can work that out in exactly the same way. So carbon has a molar mass of 12.01 and there are 6 of them. Hydrogen has a mass of 1.01 and there are 12 of them. Oxygen has a mass of 16.00 and there are 6 of them. And we can add all that together to get 180.18 grams per mole. In other words, 1 mole of glucose will weigh over 180 grams. So you can see there, these are all different substances. They have different numbers of atoms, but all of the molar masses are calculated in exactly the same way. Now, this is all well and good, but what do you actually do with it? Well, let's think for a minute. I'm going to start with a very simple example, and hopefully everyone can follow exactly where I've come from. So if we've just worked out on the previous slide that the molar mass of water was 18.02 grams per mole. That means that 1 mole of water has a mass of 18.02 grams. So given that fact, if I asked you how much 2 moles of water massed, because it doesn't really weigh, it's a mass, not a weight, if 1 mole has a mass of 18.02 grams, then 2 moles must have a mass of 36.04 grams. So we're simply doubling it. Does that make sense? Hopefully that makes sense. If it doesn't, leave me some comments. Similarly, if we want to work out the mass of 0.5 moles of water, well, that's half a mole, so the mass must be half of the mass of 1 mole, which would be 9.01 grams. Okay there so far? Let's hope so. And then, so the final question then comes down to a question like this. If we know that 1 mole of water has a mass of 18.02 grams, if we have 100 grams of water, how many moles would be present in there? Well, we can start off by working that out fairly roughly. Okay, 1 mole is 18 grams, 2 moles is 36 grams, 3 moles would be 54 grams, 4 moles would be 72 grams, and 5 moles would be 90 grams. 5.5 moles would be 99 grams. So it's going to be just over 5.5 moles. However, that's not particularly accurate, but it's a good way to check that we've got the right answer. You know it's going to be somewhere just over 5.5. The way to solve it, of course, is to take that mass of 100 grams and divide it by our molar mass of 18.02 grams. And here we go, 100 grams divided by 18.02, and we get an answer there of, 5.55 moles, rounded to 3 significant figures. So we take the mass and we divide it by the molar mass. All right. So we can turn that into an equation. All those calculations we've been doing have been based on this equation. You've worked it out through logic, but this is the math equation that you don't need to figure out with logic all the time. So the number of moles is equal to the mass divided by the molar mass. So the symbol for number of moles is M. The symbol for mass is little m, M for Mary, and the symbol for molar mass is capital M. Okay, or units, moles, grams, and grams per mole. And you will always be able to find the molar mass straight off the periodic table. Okay, so this video has explained to you how to convert between moles and mass, backwards and forwards. In my next one, we will be talking about how this is actually applied in a chemical reaction. I'll see you there. Good luck with this in the meantime.